Okay, so in this video I will try to show you how to prepare your dataset for analysis using Imaris. So what we have here is a dataset already converted into the IMS format, so the Imaris native file format. And if we look at it here by opening it into Surpass, we can see there is a lot of wasted space, and the resolution is very high and maybe not needed for what we intend to do, which is detecting some signal here in those small cells as well as those big cells. So we will do several steps, including cropping, resampling, and defining some masks, and maybe also a bit of filtering to clean up the image. So first step, crop the unnecessary area. So in order to do that, we go to the edit menu here and crop 3D like this. So we can adjust the size of the region using the yellow borders here of this region, but you can also type the numbers here if we want to. Press OK. So now we are looking at the tissue without unnecessary parts, but we will still want to reduce a bit more the size of this dataset for to allow a bit faster processing. So we go here to edit, resample 3D. So what we will do here is take maybe half the size in X and Y of this dataset. We will want to keep the Z number here because it's already very low and we don't want to reduce it further. So let's put something like this here. Don't mean to be very precise. There's interpolation going on anyways. Okay, and what you can see here is that the dataset doesn't look too bad, even with half the resolution. So the next step will be to filter a bit the channels, especially the green one, since there is a lot of background here. So in order to do that, we will do two filters, one which will be background subtraction to get rid a bit of the background, and the other one will be a median filter to clean up a bit this noisy signal. So to do that, we go to image processing here, and let's zoom a bit inside the image. So we have the original image here, the preview here, and we can toggle on and off the different channels if we want to. And here we will apply the several filters. So the first one will be to apply background subtraction. So if we click this here, you can see the preview in the screen below, and here this is the only parameter we have to adjust here. This is the filter width. So usually the value we want here is the size of one of those cells. So let me just go back a minute here in the slice view. So in the slice view, when you click at two different locations, you can see a measurement of the distance here. So for instance, if you want to measure the diameter of a cell like this, we see that it's around 12 microns, and to be on the safe side, let's use 20 here. So let me just go back to image processing here and select for the green channel background subtraction and use 20 as a value here. So with this setting here, we can see, maybe let's choose another area like this here, that it already looks a bit better than here, but the signal is still very noisy. So to address this problem, we can add a new step here, which will be either Gaussian filtering or median filtering. To make sure we don't smooth out the small cells, we will use the median filter. And we have the choice to use a 2D median filter or one that takes into account also the slice above and below it. So I think it's more accurate to use the second option here. So obviously it takes time, since it's still a very large data set, but I think it's worth it. Okay, so yeah, it looks a bit more precise than before. So we will keep those parameters, so background subtraction plus median filtering. So we could do this also for the yellow channel here for side 3 in this case, but since we will base on the second video the spot detection only on the green channel, I think it's not needed at this point to do this. So let's press OK and let the program do the processing for the whole dataset now, and then we will go to the final step, which is to define specific regions for processing. Okay, here we go. So if you have a look in the 3D view now, just move this window a bit here. So we can see a bit better now the green signal. If it's not the case, you can still change a bit the display here by changing with the right click here, maybe the contrast a bit like this, so it's a bit more visible. So what we want to do here right now is define several regions for the analysis. So there are several ways of doing this. We can process just a specific region of interest, or we can mask some regions. So here I will do some masks, since the regions of interest, the ROIs, we can define by using any of those tools here. It's usually a square, which is quite limiting here. So what we will do is use a surface module. So here we go. So let's add a new surface, but instead of trying to detect something, we'll create it manually. We don't need to classify the surface, and we don't need shortest distance calculation here. We skip everything and we go directly to manual drawing. And here we will click on draw to activate the pen. And what we see now is a view of the different slices here. So I will start by defining a region here. So I click like this around my region, like this, and move to the next slide. So I don't need to do all the slices here. Like this, make sure it's closed. Next. So like this, up to the top. Like this. So, and then we can create a surface. So normally once it's done, we can go back here, and now we can see the region that we have created. So what's nice with this is that if we go back to the edit tool, here we can see mask selection, and by doing this we can create new channels that only contain the signal from within this this region. So let's do this here. So we can leave the values by default, so everything outside this region will be set to 0. So we will do this for the blue channel, again for the yellow channel, and one last time for the green channel. Okay, so now we can maybe rename the regions. So let's say this is region 1, same goes for the side 3. It's always nice to give proper names to the objects you create, even if it's channels. It will be easier to identify what you are doing later on, like this. So now if I toggle off the visibility of all the channels but the new ones that I've created, and if I switch off the regions, you can see that what's left is only this region that we have defined. So we can do the same here. Let me check back the green channel for the original dataset and define the second region, and this time it will be a bit more precise. So I will create a new surface here. Again, no need for classification, skip the automatic creation and edit manually here. So let me just reset here the view, change the slide position to the original, and let's draw. So here we are interested in this region here. So let's start something like this. Here we want to exclude, so we can still zoom in, exclude this part. Sorry. Because the signal here is very noisy and can be mistaken for the cells, so we will try our best to exclude it. So I will go a bit faster here, but you get the idea. This. done. So here we have defined the region for one slice position. Let's go up a bit and do the same. Here. So obviously here I'm going very fast, and this is just for the sake of this demonstration. I don't want to spend too much time defining this region, but if you want to do this analysis work properly, you might want to be a bit more precise than what I'm currently doing. Okay. Then we can create the surface here, and we can go here to the edit menu and mask the selection. So mask selection, make sure we still choose the original data set here. Press OK, and do the same for the two other channels, like this, like this. And let's finish by renaming the channels. This time it will be region 2 for all the 3 new channels. Region 2. Okay. So this is now how it looks like with just the region 2 enabled. So this way we can do analysis on separate channels as well as separate regions. Okay, so next video will be on the analysis itself.